Hi everyone, welcome to Ultimate JavaScript. Today we're going to solve another question called generate parenthesis. So the question suggests given n pairs of parentheses, so n is a number that we're going to give as a input to our function, and the function need to generate all combinations of well-formed parentheses. Okay, well formed in the sense the parenthesis should be valid. When it is valid, when every open parenthesis must have a closing one, right? Then only we can call it valid. So this is a recursive recursive problem. Let's explain the same on the whiteboard. Now assume that the number is 3, right? So now at the beginning, our opening parenthesis, number of opening parenthesis is 0, and number of closing parenthesis will be 0, right? So in this particular case, to make our string valid, we have to assign the opening parenthesis, right? So we're going to start with this. And again, we can now, since the number of opening parentheses is less than our given number, so we can again assign more opening parentheses. Same way, but here in second case, right, the number of closing parentheses is less than opening parentheses, so we can assign a closing parenthesis. Okay, so here the number become 1 1, here they become 2 0. Now if you again implement the same rules, this will become C C C, or three opening parentheses, and this will become, again, the number of closing parentheses is less than opening parentheses, so we can also implement one closing parenthesis. Here the same thing, we can add a open, or we cannot add close here because the numbers are same. Now then, here now we don't have it already 3, right? So only thing we can add now is closing, so this will become this. But in this case, again, the number of opening is less than 3, so we can add more. But here again, the number of closing is less than opening, so again we can add one more. Sorry, it's going out of boundary, so let me draw here again. So now let's start from here, right? In this case, like C C C, and then we have okay. In this particular case, we already have three opening parentheses, so you cannot add more, so we only can add the closing one. And here we also can add 2 closing, right? Here only closing 1, here also 1 1 1 2 2, and it will become 1 1 1, this one. So when number of opening and number of closing became same, we can push it to our result. Now let's solve this one. Okay, so this will again can take one more opening, but closing is less than opening, so it also can take closing. So sorry, this, yeah. And now if you go down again the opening number of opening is less than 3, so we can again add one more, right? One more. So no, number of number of opening is already 3, so we cannot add more, but we can add a closing one. Here we can, number of opening is only 2, so we can add one more. We're gonna go here, only thing we can add is a closing one. Yeah, so this is a valid one because a number of opening and number of closing became 3, so we have to push it to our result. Same here for this one, the number of opening became like 3, so only thing we can add is now closing, so this will become, this is a valid one, we have to push. Now only thing remain is this one to solve. We can solve that as well. So if you solve that, it will become like 1 2 1. We can open it 1 2 1 2, this one, then 1 1 1 1 1 1. So this will end with this one, so that will end with this will end with this one, and the last one we can add one more, right, with 3 opening and closing. So that is how we're gonna derive all the combinations. We're gonna check like for every opening, if the opening is less than the given number, that is one. We can, if that is the case, we can add an opening one, and then if the closing one is less than the opening one, then we can add a closing one as well. And at the end, when the number of opening and the number of closing matches, at that time we're going to push that string to our result. So let's implement that using JavaScript. So first thing here, we have to create a result, right, that where we're going to push the results. So let result equals to this one, and then we need to create a function that we're gonna call recursively, right? So function create, okay, create, and it will take number of opening, let it call I, or you can call open, right, open, and number of close, and the string, right? Now the best case here is if the number of, if the open equals to n and close equals to n, then we have to result dot push string. Then we have to set our string to because the string that we are populating, we're gonna reset it. After resetting, we can return or break our recursive function. Now we have to check if the open first, this need to be the first condition, that is open is less than the number, right? Is open is less than 3 or n here. Then we need to create, what are you gonna do? We need to increase our open counter by 1, our close counter will remain the same. Then we have to add we can add opening parenthesis to our string. So it will add the first thing we're gonna send to our function is a blank string. So the first time when it encounter this statement, it's gonna start our string with a opening bracket. Simple. Then the second condition we're gonna check if close is less than open, then we're gonna again call the same recursive function. Now open will remain the same because we are not gonna add a open bracket. We're gonna add 1 to our close pointer in this case, and here to the same string we're gonna add a closing bracket. I think that's it. I think this should do the trick and return us the answer. At the end we need to call this function, the create, and we have to start from 0 0, and strings need to be also blank. And after our recursive calls ended, our result should have the answer. So return result. Okay, so we're gonna test for this test case where the input is 3 and it should return us all these 5 parentheses. So let's run the test case. So it passed. So thank you very much for watching.